Hello everyone, welcome back to this video series on clinical SAS programming. So in this video, we will see how to make use of arrays to transpose data which is collected in wide format to long format. So if you see the input data, we have the information related to vital signs of the subject is collected. There is one record per subject per visit and three vital signs, which is systolic blood pressure, diastolic blood pressure, and pulse are collected. So these are present as variables, but we need to present this information as rows if you see in the output. So we are creating one row per each vital sign collected, and that each vital sign is indicated in a variable named VS_testCD, and the actual result is stored in a variable called VSORRES. Along with these two variables, we are also interested in creating a new variable called VSORRESU, which is for VS vital signs, OR is for original, RES for result, U is for unit. So we are creating, we need to create this additional variable as well in the transposed or restructured data set. So we will see how to achieve this end result with a piece of code, and we'll also try to understand how it actually works at the level of PDB, which is program data vector. So we have input data set with the variables sysbp, diabp, and pulse. We need to create new variable called vs_testcd, which contains the values sysbp, diabp, and pulse, and the values in sysbp, diabp, and pulse variables have to be stored in a variable called vsorres. Along with this, the manually assigned unit values have to be presented in a variable called vsorresu. So we are going with the assumption that the test CD values have to be sysbp, diabp, and pulse. Along with this, we want to present the units as mmHg. Let's assume that this information is given somewhere in the protocol or somewhere that these these will be the units for the collected uh, vital signs. So let's say pulse is collected in terms of beats per minute. So we have the actual results, the test CD to be assigned, and the units to be assigned. So we will now see the code which is written here to get the end result. So here we are reading an existing data set, which is, let's say this was called as VS, and then creating a new data set named VS02, which is the output data set. So in here we have written a length statement to create and assigning lengths for the variables which are to be newly created. The first one is vs_testcd, for which we are assigning a length of 8, and so as we have used the $sign, this means that it will be a character variable. Similarly, we have assigned a length of 30 for two additional character variables, which is vsorres and vsorresu. And here comes our key logic. So we have three array statements here. So array in SAS is nothing but it is meant for temporarily grouping variables or some explicit text here. So here we are temporarily grouping sysbp, diabp, and pulse variables. So instead of referring the systolic blood pressure, diastolic blood pressure, and pulse by their original names, so we can refer them with an indexed array name value. So with this syntax, what happens is, if you see, so this can even be referred like by systolic blood pressure can be referred by direct variable name, or we can refer this variable. We have given the name of results to this temporary grouping. So results 1 is nothing but our sysbp. So diastolic blood pressure is nothing but our results 2, and pulse is results 3. So we can refer this sysbp variable as we have assigned this results keyword for this grouping. So as we have listed three variables, the dimension of that array will become 3. So we have results 1, results 2, and result 3 assigned for sysbp, diabp, and pulse. Similarly, in the second array statement, so we are assigning the testcd values which are to be displayed in vs testcd variable, which is sysbp, diabp, and pulse. So here, if we see, so this one we are putting in another array named testcd, and again we have listed the dimension as 3, which means that there will be 3 values. If we do not specify this keyword temporary, what happens is SAS automatically creates 3 variables named testcd1, testcd2, and testcd3. So, but we do not want these to be created as variables, so I have used the keyword temporary. So, which means we can refer testcd of 1, testcd of 2, and testcd of 3 during the processing, but they will not be created as new variables. So one thing to note is, if you are referring a variable or specifying a variable on the array statement, so if it is present, so it would refer to the existing variable. If that variable is not present in the input data, so it creates that new variable. So as we do not want that variable to be created, we are using this temporary keyword. So here this can be referred with testcd1. The text sysbp can be referred with the array name of testcd1. This can be referred with testcd of 2, and this can be referred with testcd of 3. Similarly, we have created one more array statement, and this we have named it as units, and again we have specified the dimension of 3, and so which we have assigned the values mmHg, mmHg, and beats per minute. So for both systolic blood pressure and diastolic blood pressure, the units were mmHg, so we are assigning it parallel to each of these variables. So, and this mmHg, first mmHg can be referred with units of 1, this can be referred with units of 2, and this can be referred with units of 3. So this is how we are making use of array to temporarily refer an existing group of variables, or temporarily refer some explicit text values. So now comes our key part, wherein we are making use of a do loop. So in the do loop, we are saying that do I is equal to 1 to dimension of results array. So here we have specified that results array is used to group 3 variables. So the dimension would be written here as 3. So we are technically asking SAS to loop 3 times. So from 1 with the value of 1, 2, and 3 in the I variable. So, and next we are creating vs testcd variable, vs orres variable, and vs orresu variable based on the array references. If you see, results of I, units of I, and testcd of I. So we are referring the names of the variables or temporary values using array references here. And then we have written an explicit output statement, and then we have used call missing option to set the newly created variable values to missing. We will see in the when we are trying to go through the flow why we have to use this call missing when we are using this syntax. Otherwise, if we do not use this, we may get some false positive results on some of the rows. So, and then we have written a keep statement to keep only the required variables in the end. So now let me just clean these things up. So now let's say SAS is processing this first observation. So when it reads the first observation, the value will be 1001, visit num1, sysbp of 120, diabp of 80, and then pulse of 72. So these values are coming from our input data set, and then these variables are being created in the code here. So let's say now SAS is processing this first observation, and it has reached this do loop. So here we are looping it thrice. So do I is equal to 1 to 3. So the first time, so it is looping for I is equal to 1. So what happens when I is equal to 1 is being processed. So here for VS test CD we are saying test CD of I. So the value in I is 1. So which means this will become test CD of 1. So test CD of 1 is nothing but our value sysbp. So this is the first value assigned to the test CD array name. So which is sysbp. So we are making this assignment of test CD of 1 to VS test CD. So this will become sysbp here. And then here we are checking in the next statement. So if not missing of results of I, so results, the I value in the first loop is 1. So results of 1, which means, so results of 1 is our sysbp, which means if sysbp is not is equal to missing, then vs or res is equal to, so again this will become sysbp converted to character and then stripping. So vs or res will get a value of 80, and then the third next if statement gets executed. If vs or es not is equal to missing, then vs or esu is equal to units of I. So as I is 1, so units of 1, so which is nothing but units of 1 is mmHg. So again if you see, so it will refer the first value in this temporary array list. So if is VS or RES not missing? Yes. So what happens then? Units of I, which is unit of 1, which is mm of Hg, gets assigned to this. So this is how the PDV gets built. And after that we have an output statement here. So what does output statement do? So whatever is content is present in the PDV, that gets returned to the output dataset. So this is now returned to the output dataset. And in the next step, we have set like call missing of VS test CD, VS ORRES, and VS ORRES2. So which means, so we are asking these values to be set to null with this call missing function. So these three values are now set. So now what happens? The next thing, so I will now become, so let me clean these things up again. Now, so we have asked SAS to loop this entire thing for 3 times. So now I is equal to 1 was completed. Now I is equal to 2 is being executed. So then this is being done. So VS test CD is equal to, as I values 2, now this becomes test CD 2. So test CD2 is nothing but our diabp, or this test CD of 2 is now diabp. So this will become now diabp. And then if not missing of results of 2, so results of 2 is nothing but diabp. So is results of 2 not missing? Yes. So which is 80. So this becomes 80 here. So and then the next statement, if VS or RES not is equal to missing, then VS or RESU is equal to units of I. So units of 2 now, which is nothing but mmHg. So that gets assigned. So and then we have our next statement, which is our output statement. So this gets written to the output. Now we see we are still processing the first observations, but in the output dataset already 2 observations are written. And then after the output statement, what we are doing, so we are setting the newly created variables to null. So in the PDV, what happens is, so we'll have these values become null. So let's clear these things as well. So we have written twice and these values are set to null. So the next thing is that I is equal to 3. So as we have asked it to loop for 3 times, the third time the I value will be 3. So VS test CD is equal to test CD of I. So which is test CD of 3. So test CD of 3 has a value of pulse. So this is the third instance. So we'll have a value of pulse will be assigned. And then if not missing of result of I, then VS ORRESU, VS ORRES is equal to put of result of 3. So result of 3 is pulse. So the value 72 would be assigned to VSORRES. And then if VSORRES not is equal to null, so which is units of 3. Units of 3 is beats per minute. So beats per minute would be assigned. And then because of this output, so this will get returned to the output data set. So now first observation has been outputted thrice for once for each of the three variables. So now we have all the required records created based on the out of first observation. And now we will see what happens in case of third observation. So the similar processing would have happened for second observation as well, but I want to show you the third observation in specific too, because I want to highlight why call missing should be used. If not, what would happen? Okay, so now let's say third observation is being processed. Let's clear this as well. So 1002 visit num1, sys BP of 140, dia BP of 90, and then pulse has a missing value. So now let us try to assume that we do not have this line of code. So what will happen now? The this observation, third observation is being processed. Again, it will repeat for 3 times. So the first time I is equal to 1. So what will happen? Test CD of 1 is sysbp. So sysbp would be created, and then VSORRES will get a value of results of 1 on the third record. Results of 1 on the third record is sysbp 140. So VSORRES will get a value of 140, and then VSORRESU gets the value from units of 1, so which is mmHg. So this is done. So now the output statement is present. So this gets written to the output. Okay, and now it has to loop for the second time. Now I is equal to 2 is being executed. So which means test CD of 2, results of 2, and units of 2. So we have not reset these things to null because we are assuming that this call missing is not there. So what will happen? So these values still remain here, but when this line is being executed, vs test CD is equal to test CD of I, which is I is equal to 2. So these value will be overwritten with diabp. Okay, this value will be overwritten with diabp, and then for results, VSORRES results of 2. So which is result of 2 is diabp value, which is 90. So this gets overwritten with 90, and then uh, our VSORRESU, which gets the value from units array, which is again this mmHg is overwritten with mmHg. So again this gets returned to the output because of this output statement. And then let's say this is being processed for I is equal to 3. So again vs test cd is equal to test cd of I is nothing but here 3 here. So this diabp will be overwritten with pulse, and then here is the key thing. So if you see, we have written this if statement, if not missing of results of I, which is results of 3, which is pulse. Results of 3 is pulse. If not missing of results of 3, then VSORRES is equal to the value from results converted to character and then put. So as this part is not true here, so what would happen? VSORRES value would not be assigned. So this would still remain 90. Okay, and then if VSORRES not is equal to missing, then VSORRES U is equal to units of I. So units of I is units of 3, which is beats per minute. So as VS over RES is not null, but this is not null because on this observation or on this iteration for I is equal to 3, the 90 is not overwritten with the missing value. We have asked if not missing of results of I, then only convert it to. So this 90 remained in our PDV from the previous iteration, which is I is equal to 2, which was for results of 2, which is diabp. This 90 value is actually the result for diabp, but it is not pulse, but it remains in PDV. So this will become beats per minute. So what would happen if we do not use this call missing? So we would have the value of 90 retained from uh, previous iteration, which will still get this as 90 beats per minute, which is actually wrong. So if we had reset this to missing, so what would happen? So now let's say that we have this call missing in between I is equal to 2 and 3. So in between when we had that missing, so what would have happened from one iteration to the second iteration, these values are being set manually set to null. So if I after I is equal to 2, what would have happened? That diabp would have been made null, VS over RS would have been null, and VS over RSU would have been null. So now let's say that I is equal to 3 is being processed with this call missing function. So results of 3, test CD of 3, pulse would be there, and VS over RS will we get a value? We are saying that if results of 3, which is if pulse is not is equal to missing, then only assign the value of uh, that to the VS over ES value. So as we do not have anything, so this would be null when this being executed. So and then if VS over RES not is equal to missing, then VS over RESU is equal to units of 3. So as this is missing, so this will also have a missing value when this line is executed. So this gets outputted. So as is. So what would be the value there? So this would be the case. So it is mandatory that you set this to these newly created variables to null, so that after you output the current record to the output data set. Otherwise you would get some false positive or error messages. So this is how you can make use of arrays to transpose data from wide structure to long structure. So So what is the advantage of using this approach when compared to, so the same thing could have been achieved using three output statements or three loops. So maybe I'll show you that piece of code which could be an alternate without using arrays. So we had three test CDs, so we will have three blocks of code, once per each test. So but if you get more test CDs or more vital signs collected, so all you have to do is like you will have to, let's say you have 10 such blocks, so you would need to add the same lines of code for all those 10 blocks. So the advantage with arrays is that your core code still remains the same. All you need to do is increase the number of variables here and the associated values here. So this core logic will still remain the same. So you get 10, 20 or 30 or how many ever test CD values or variables available you want to transpose this way. So all you need to do is you will have to specify it here. So assume that you have to create conditionally like some 5, 6 conditional executions, or here we have seen the examples of only 3 variables, but there can be more variables also to be created. So in that case, with the manual approach, you would end up having those many number of lines multiplied by equal to the total number of variables collected. So let's say if you have 4 or 5 other variables to be derived based for each test CD. So you'll have that 4 or 5 additional conditional logics written for each block. So your code becomes like not easily manageable. So with arrays, so as your core logic is only written once, so you can elaborate it or include more tests or values here on the array statements. So hope this is helpful. Thank you for watching. Keep learning.